Okay, the first question or the initial questions are single choice correct. The first question is single choice correct. Okay, you can reply your answers.
These.
Yes. Yes, the correct answer is D. The gas P will be carbon monoxide, right? And carbon monoxide gas can react with I2O5. It can react with Ag2O. Again, it can react with nickel metal. But CO gas is a neutral oxide, therefore it will not react with water. Okay, so its answer is D. And the CO gas, which has been identified as the P gas, can react with I2O5. It can react with I2O5. It will give product I2 plus 5CO2. With Ag2O, it will give us silver and CO2. With nickel heated metal in the Mons process, NiCO4 will be formed. But in case of water, no reaction will be there. So this is actually the mixture of CO and CO2. Let us move to the next question. This question has already been asked in IIT Advance 2017. Okay, whatever problem you will be facing in this question, you can ask. First attempted. Okay, if you not having any doubt in this question, then you can just tell your answers and we can proceed further. So you have to ask your doubt in this question, whether you have the doubt or not.
So in this question, how will we know what product is being formed when the reaction of X is with excess HCl at room temperature?
See, the basis of the reaction is that the first complex is like F.6H2O. This is given as X. And in excess of aqueous ammonia, this pink color compound converts into an octahedral complex Y in the presence of air. Okay. So whatever this M plus 2 will be there, it will get also has a tendency to convert into its higher oxidation state in the presence of air and form an octahedral complex Y. Okay. So we can write first of all the equations. Two major equations are given in this, like M and H3 whole 6. And if we consider it as, because it is given as a 1:3 electrolyte, then we will be considering it as chloride as 3 and this as a complete cation. So we are considering it as it is going into M plus 3. Okay. So this will be a Y complex.
Yes, sir.
Which will be octahedral. The reaction of X with excess of HCl at room temperature results in the formation of blue colored complex Z. So this will be a blue colored complex. This was a pink color compound. So basically the chlorides and water, they are weak field ligands. So in this situation also, electrons will remain unpaired and no oxidation will take place. This M will be in +2 state only. In the lower oxidation states, it might be forming coordination number 4 complex. So it might be a coordination number 4 complex like this, because it is having lower oxidation state. So chlorine is a weak field ligand. So the overall format of the complex might be this. And now the next hint will be obtained from this step. The calculated spin only magnetic moment of X and Z is 3.87. That means it is having 3 unpaired electrons both, whereas it is 0 from the complex Y. Okay. So now we can identify that if we are having 3 unpaired electrons, when we are having weak field ligands, and when this M plus 2 is having 3 unpaired electrons, right? And this M plus 3 in a strong field ligand like ammonia, it is having 0 unpaired electrons. Okay. So what kind of metal ion it can be? Metal
Cobalt.
cation. Yes. So from here we can get the idea, and from this also pink colored aqueous solution compound like a COCl2.6H2O is a pink color compound. Okay, so from that also, that is information, because it is a invisible ink example, like anhydrous COCl2 converts into pink when it becomes hydrous. It is also a colorless moisture detector. It is a colorless moisture detector. The specific compound is used for moisture detecting in the walls or the surfaces in which moisture is not visible actually. So COCl2 has a property when it combines with water, it shows pink color. So one hint can also be obtained from that, but if you forget that point, they are giving the hints in the later on lines, we can say. Okay, fine.
Okay, sir.
Sir, isn't COCl2 blue? Anhydrous.
COCl2, if it is colorless moisture detector, I think COCl2 aqueous solution or the compound of its chloride is actually blue. Okay, so COCl2, I think it is a colorless moisture detector, means its color is not blue, but blue changes to pink. I don't think so. I have to check the color of COCl2, exactly color of COCl2.
We get in borax bead test, no?
But in that, we are not going to check the exact color of COCl2. No? In that, in its solid form, I think it is blue in color. Okay. So colorless moisture detector, we can say it in the powdered form maybe, or it is a moisture detector. Simply we can say it is a moisture detector. Okay. It is in solid state, it is blue. Okay. So it is asking like COCl2 actual color is blue, but whenever it is with the water, it converts into pink. Yes. COCl2 solid is blue. It is also blue. Any other doubt in this case?
No, clear, sir.
Okay. Fine. Let us move to the next question.
Sir, can we be sure it will be tetrahedral complex?
In case of COCl4 2 minus?
Yes, sir.
COCl4 2 minus complex means it is cobalt plus 2, and the configuration will be 3D 7 in this situation. So in this situation, it will be, yes, tetrahedral complex. Coordination number 4, it can't be inner orbital complex, because in case of inner orbital, inner D will be available. Yes, inner D will be available in this case. So here, COCl2 will be DsP2. The tetrahedral complex Z, yes, it will be tetrahedral because it will not be using its inner D. See, the splitting will be according to weak field ligand, right? If we are having weak field ligand, then the splitting will be not of that square planar type. Therefore, the complex will be tetrahedral only.
We are rejecting
So
octahedral because it will not form inner complex.
In case of octahedral also?
We are rejecting octahedral because it cannot form inner octahedral complex.
Yes. Yes,
Okay.
yes, yes. No. See, molten LiCl, molten NaCl, we want the electrical conductivity means the free ions. So in case of molten LiCl also, LiCl will be having a predominantly covalent bond, covalent characters. Okay. So dissociation into the ions is more in the case of NaCl because it is predominantly ionic compound. Okay. So basically, we have to think when we are discussing LiCl, NaCl, or NaCl or MgCl2, we have to first think about the charges. But LiCl is predominantly covalent, NaCl is predominantly ionic. So in this situation, NaCl will be having more electrical conductivity. But in case of aqueous LiCl and aqueous NaCl, the dissociation will take place. Li plus will be there, Na plus will be there. So how we will decide in aqueous LiCl?
Ionic mobility.
See, so Li plus aqueous and Na plus aqueous. So which is having better electrical conductivity? Na plus. Na plus will be having better electrical conductivity because Li plus aqueous will be having hydrated radius which is larger than Na plus hydrated radius. It is having larger hydrated radius. So mobility will be very low. So NaCl, aqueous NaCl will be more conducting than aqueous LiCl. Okay, getting the idea?
Yes,
So
sir.
it will be a little bit confusing when we are writing molten and when we are writing aqueous. In the case of molten LiCl, there will be bonds like covalent bond between Li and Cl. Therefore, the answer is getting difficultly. And in B case, now C case you can easily predict because it will give us Na plus and it will give us magnesium plus 2. So in case of electrical conductivity, it is also proportional to the charge. Okay, charge, and then we can say the hydrated radius, inversely proportional to hydrated radius. So in this situation, magnesium plus 2 will be having more electrical conductivity. But in case of cis and trans, we will just simply check the dipole moments. And their dipole moment is cis is more polar than trans. So more electrical conductivity will be there in case of cis. So correct answer will be D.
Sir, even in molten state, there won't be any dissociation. So why does it matter? It's ionic or covalent.
See, in the case of molten NaCl, it will be ionic. And LiCl is covalent. That means the charges are actually not present. So ionic and covalent, which will be having better electrical conductivity, if they are not dissociated also, then also the tendency to move towards electron will be major in the case of NaCl.
Overall molecule is neutral, so
In case of molten NaCl, like NaCl with NaCl, it is having a gap. But now for electrical conductivity purpose, we are just discussing the mobility of the ions in that situation. And now if we are having molten NaCl, then if we put a condition that now electrical conductivity is, so then we have to discuss that part, that Na plus and Cl minus migration towards the electrodes. If we are giving the condition electrical conductivity, then we have to think over the migration towards the electrodes. So it will definitely matter whether the compound is predominantly ionic or covalent.
migration will happen if the bond is broken, ionic bond is broken. It won't broke until we add a solvent in it.
See, if the small, we can say that the polarities Na plus and Cl minus will be there, na?
Yes, sir.
On that basis, we are saying that Na plus is having larger polarity than Li, lithium.
Yes,
So in case of lithium and Na in the molten state also, which will try to migrate towards the electrode faster. The
Na
electrode
plus.
will give attraction. So therefore, these charges will be considered. Like this is having partial plus and this is having complete plus. That tendency is actually making it more electrical conductor. Okay, that tendency we can discuss actually in the molten state also, because there is electrical conductivity in molten state and in the aqueous solution, right? In these two areas, we can discuss the electrical conductivity when they are in molten state and when their aqueous solution is present, right?
Okay.
In the solid state, there will be no conductivity. So with respect to that solid state, when it will come into the liquid form, it will have more conductivity than the solid state, right? We say na that NaCl molten is more conducting than NaCl solid. On what basis we say that? By these charges, that being a liquid, it will have more tendency to attract towards the electrode, right?
Okay.
Okay, fine. Okay, anybody solved question number 4?
So D.
Yes, the correct answer is D. In this situation, it has been asked that same order of dipole moment and boiling point. So everybody knows the answers. Like in case of A, ortho meta para dichlorobenzene is there. So what is the order of dipole moment? Ortho, then meta,
Ortho
then
meta
para.
para.
Yes. And in case of boiling point, the correct order is actually ortho, para, and then meta. In case of B, dipole moment is CH3Cl is greater than CH3F, and then CH3Br, and then CH3I, right? And the boiling point is here directly proportional to the mass.
Yes, sir.
So it will be exactly opposite of what we have written. CH3F, Cl, Br, CH3I. So here also it is not matching. In case of CH3Cl, CH2Cl2 in this situation, the dipole moment is again comes in the decreasing order. And boiling point will be here also proportional to the mass. Okay, now in case of D, dipole moment and boiling point are here proportional, because cis will be having more dipole moment than trans and having more boiling point also. Okay, so answer is D, is single choice correct question. Okay, try to solve next. Yes, in option A.
In boiling point, can you explain between para and meta?
I think the explanation is not going to be appropriate, because in case of para, dipole moment is actually 0. So we just learn it as a database. So it is given in the NCERT also without any explanation. Okay, it is asking the incorrect. So why A, B, C are not incorrect? In case of CaC2O4, it will break at a certain temperature. Will give CaCO3 and CO, right? If we start writing the cases, if we consider it as a CaC2O4 at a certain temperature T1, it will break into Ca, CO3 and CO. And at a higher temperature, T2, it will break into CaO and give CO2. These two temperatures, like a CaCO3 is not that much thermally unstable. Therefore, we will be having two different temperatures of oxalate breaking and of carbonate breaking. Okay. In case of B also, we know that Na2CO3 do not break further. So only step 1 is possible. In case of C, Li2C2O4, that Li2CO3 is unstable. So it will break at a temperature almost same to the temperature of oxalate breaking, because it is thermally unstable. This is thermally unstable. Fine. And in case of K2C2O4, both steps 1 and 2 not possible. Again, this is wrong, because step 1 is possible, like Na2C2O4. Step 2 is not possible. The answer will be D. Okay, I think option C and option D are very straightforward. We know that experimental molecular weight of acetic acid becomes double due to the hydrogen bonding. So it is obvious part. Solubility of NHCO3 is also less than KHCO3, because in the both cases, intermolecular H bondings are there, but of the different patterns. NHCO3 is having very strong form of H bonding, and KHCO3 is not having, because it is like dimeric form, but NHCO3 is like polymeric form. So they both are very straightforward options. Now for option B, first of all, basicity order of isomeric alcohol is like 1 degree alcohol is having less basic, and the basic nature is increasing. We can directly write that in this matter, in this pattern. It is increasing. So it is very simple to explain it by the inductive effect plus I. The plus I power is increasing, so basic strength will be increasing. So no exception is actually creating in this answer, in this order. No exception is creating due to H bonding. They might be doing H bonding, but that basicity order is not playing the key role in the explanation of this order. Like how we will do that explanation, like 1 degree will be having more H bonding, 2 degree will be having less, 3 degree will be having even less because of the hydrophobic part. But that is not a playing role in explanation of this basic strength, right? So option B will be ruled out. Option B. Now option A, less solubility of noble gases in water. That is because noble gases are insoluble in water. But why? They are insoluble in water because water is having that we can say that solvent-solvent attraction is more than solvent-solute attraction. So the H bonding in water is stronger than the dipole-induced dipole attraction of noble gas in water, right? So less solubility of noble gases in water can be account for, we can say that water-water attraction is better than water-xenon attraction, if we take xenon as an analysis. So what kind of attractions are there? We can say H bond. And here we will be seeing dipole-induced dipole attractions. This attraction force is stronger. Therefore, we can say that noble gases are insoluble in water. So H bonding of water is playing role in the explanation of less solubility of noble gases. Whenever we explain the solubility of anything, we first of all check the solute-solute interactions, solute-solvent interactions, solvent-solvent interactions. Okay, so in that manner, the H bonding of water takes a role. Therefore, answer will be B. More appropriate answer will be B. Yes, option A is a little bit confusing one, because the order of solubility. The order of solubility of the noble gases is like helium, neon, argon, krypton, xenon. This will be the order of solubility. Although they are insoluble, but the relative solubility in water order will be this. They are not asking about the order. They are just asking about that they are insoluble in water. Why? Because water is having H bonding. So in that manner, the option is coming. So A is not the answer. Answer will be B. Okay, a little bit confusing question comes when hydrogen bonding explanation has been asked. Okay, such type of question has already been asked in JEE. So it is actually framed a question on that basis. Okay, getting the idea why A is not the answer. Any doubt in any option?
Sir, do we have an explanation for that order of solubility of noble gases?
Yes, molecular mass, atomic mass. If they have a similar type of forces of attraction, then the solubility in water will be proportional to their molecular mass, like forces of attraction. Okay, any guesses? Lewis acidic character?
Option B, sir.
Option D.
Okay. What is the basis of the Lewis acidic character?
Ability to accept lone pair of electrons.
Yes. So that will be proportional to the more partial positive charge on the central atom, right? So more attraction directly proportional to positive charge density on central atom. But first of all, the Lewis acidic character comes because of the vacant orbitals. Available of vacant orbitals. These two hints will be required to solve this question completely. So in this situation, the more partial positive charge will be on the phosphorus. Okay. Then it will be on CCl4 charge density, then SiCl4, then AlCl3, then MgCl2. But among all of these, CCl4 is not a Lewis acid. It is not a Lewis acid. Why? Because although partial positive charge will be there on the carbon, but in the normal conditions, it is not having vacant orbital, so it is not a Lewis acid. So we will be discussing, when we will be discussing its Lewis acidic character, it will be least. So CCl4 is the least Lewis acidic character. And in all the options, CCl4 is given least. And among the rest of them, like here, +5, +4, +3, and +2 oxidation states are present, like positive charge density will be more in PCl5, SiCl4, AlCl3, and MgCl. So answer will be PCl5, SiCl4, AlCl3, MgCl2, and then CCl4. Because we are comparing CCl4 with them, and CCl4 is least, answer will be A. Okay. Any doubt here?
So silicon forms a complex with Cl minus, but PCl5 forms only in solid state. So,
but if we take about the hydrolysis reactions, then both will be reactive.
yes.
Okay. So the judgment is not on the basis of any reaction, that is on the basis of their charge density. Similar will be the order of their hydrolysis reactions also. Rate of hydrolysis, we can say. Okay. Next attempt, that question 8.
Option B. Sorry, D, sir, D.
Yes. So what are the answers? Option D and option B. Right? How we will be solving this question? Like
Is it
in A
multi-correct,
option,
sir?
yes, it is, I think, multi-correct, because I can see that B is also correct. B is also correct because it will be a chloral hydrate. Na? Chloral hydrate is stable hydrate. Yes, the answer will be B and D. Okay.
Yes, sir.
Answer is B and D. Okay. Any doubt here?
No, sir. No doubt.
Okay. Okay. Now solve next question. That is actually multi-correct. Okay. So in case of NO2 minus, NO2 minus actually can show that ambidenticity because it will be having a lone pair at a donor site nitrogen, and it can have a donor site oxygen. Okay. So there are two donor sites, and at a single time, only one will donate. That is the definition of ambident ligand. But in case of NO3, only one donor site is there, which is actually oxygen. Nitrogen is not the donor site. Okay. So NO3 is not ambident. It is monodentate only and can also not show linkage isomers. And NO2 minus is ambident. Okay, so A statement is wrong. In case of NIDMG, 6-membered ring is formed by H bonding. So in this situation, again, we have to write that whole complex, or you can just learn the answers if you want to avoid the writing of this complex. So in this situation here, OH is present. It is dimethyl glyoximate. And here O minus is present. Nickel plus 2 is present in between, and nitrogens are the donors. Here N, this will be O minus. This is N, this will be OH. Okay. In this situation, nitrogens are the donor, and here H bonding is taking place. Okay. So we have to just count the number of atoms. 1, 2, 3, 4, 5, and 6. 6 atoms. 6-membered ring is formed by H bonding. Like H bonding, the chelation pattern is of 6-membered here also and here also. Okay. So here 2 5-membered rings, like 5-membered rings by direct chelation, and 6-membered rings by chelation due to H bonding. So B is correct. Now in the case of C, D pi P pi back bond is formed when CO act as ligand. So if we take a metal complex like MCOX type of the complex, that CO will be giving the electrons to metal, and metal is going to give electrons in a back bond format that will be from the D electrons. The nature of the bond will be pi. This is a pi. We can also then a pi back bond. But the donation will be in the pi star of the CO. Okay. So D pi and back bond will be not in the P, it will be in the pi star. The type of back bond will be D pi and pi star, not the P pi. When we write P pi, when we are using P orbital, right? Any confusion here? The nature of backbone will be D pi pi star. Any confusions? That pi star will be P, but it will not be P pi. Okay. So D pi pi star P will be the actual format of the backbone.
Okay, sir.
And in case of N2H4, it is hydrogen. Both nitrogen cannot donate simultaneously to the metal because three-membered chelation is not allowed. So actually answer will be your B and D. B and D are the correct answer. Okay. Try solving next question.
So B and D.
Only B.
Only B. The nature of X and Y should be like that it will react with NaOH. Okay. So here we are given with the heating part like CaO, CO2. It will be like a PbO and CO2. It will be like a Ag2, like it will actually form Ag2O first of all, and then SO3. SO3 gas will be formed, and overall in this situation SNO and SNO and SO3 will be formed. What are the answers in this final? Okay, finally this can break into 2Ag half O2, and it can convert into SNO2 and SO2. These are the final answers. Like if we want both of this X and Y to react with NaOH, they can be both acidic compounds, or one is
Amphoteric.
acidic, the other is amphoteric, right? But if one will be basic and other will be acidic, acidic will react, basic will not react. And in this situation, this is amphoteric and this is acidic. So both will react. Again, in this situation, SO3 can react, but silver or Ag2O will not react. And SNO and SNO2 both are amphoteric.
Yes, sir.
And SO2 is acidic, right? So both of them will react. So answer will be B and D.
Sir, isn't SN only amphoteric in +3 oxidation state?
Which compound?
SN shows amphoteric nature only in +3 state.
No, both of the states are amphoteric only, but if we compare their acidic nature, acidic order, then SNO2 will be higher acidic than SNO. But all the corresponding oxides of amphoteric metals are amphoteric in nature. Okay, have you studied any where that SNO2 is not amphoteric? Is it so?
I read that SN +3 is amphoteric. I didn't see of SN +4.
SN shows only two oxidation states, +2 and +4. I think you are confusing with some other metal ion. SN is of 14th group. No? It is having only two common oxidation states, +2 and +4. Right?
Yes, sir.
Okay. Let us move to the next question.
ABCD.
Okay. Any other answers? Anybody want some more time to analyze the question? Like Mg3N2 is undergoing a hydrolysis. So it is easily identified as ammonia gas, P as ammonia gas, right?
Yes, sir.
And if ammonia in excess of O2 in platinum catalyst, so this will be forming the oxide of nitrogen, NO. Okay. So what are the P gas is ammonia? Main question will be asking P and Q. And ammonia on excess of O2 in presence of platinum, it will be giving Q gases as NO. R will be water.
Yes, sir.
Okay. So a substance R makes anhydrous Cu into colored substance, then select correct statements. Gas P doesn't undergo self-dissociation in water. Okay, so ammonia in water do not dissociate, rather it takes H plus from water, it forms ammonium hydroxide. So it is not undergoing any dissociation. Dissociation means it is not forming like H3O plus and NH2 minus. It is not forming this. It is forming ammonium hydroxide. Gas Q combines with FeSO4 solution. Yes, brown ring complex it forms. Gas Q forms colored substance with oxygen. Okay. On reacting with oxygen, it can form NO2, which is brown color compound. And gas P is used for surface treatment of steel. Okay. Is there anything regarding this? Have you studied about surface treatments of steel? Ammonia is used in surface treatment of steel. So that is also correct. So all options are correct. Right? Any doubt in this case?
Clear, sir.
Okay. Next question is a match the column. Aqueous solution of these salts are given and the reaction with this salt solution. A is K2CrO4 and it has observable change with dilute H2SO4. So we are having the observations like this. Dilute H2SO4, AgNO3, O3, acidified FeSO4, H2O2, H plus medium. Okay. So what are the changes you have observed? Like in this situation, it will convert into K2Cr2O7. Right? So there will be a observable change. Here it will form complex with Ag2CrO4, which is a red color complex, red precipitate, not complex. In case of O3, there will be no reaction. Will not react in O3. O3 is a oxidizing agent, but it is already present in its highest oxidation state. In case of FeSO4, it can convert into Fe plus 3. And in case of H2O2, it can convert into chromium plus 3. Okay, so A answer will be P, Q, S and T.
Yes, sir.
Okay. And in case of BA, BR2, let us try to recall them in this format only. Like in case of BA, BR2, in case of dilute H2,
sir, in H2,
case, yes.
In case of K2CrO4, H2O2 and H plus will give CrO5.
And after that decomposition of CrO5?
Yes, Cr plus 3.
Yes, finally we get Cr plus 3. Okay, we were on BaBr2. In dilute H2SO4, BaBr2 will form precipitate of BaSO4. It will be a white precipitate. In case of AgNO3, answer will be AgBr. In case of O3, that Br minus will simply undergo conversion into Br2. It will form Br2. In FeSO4 solution, acidified FeSO4 solution, again it will form sulfate, barium sulfate. And H2O2 H plus, it will form Br2 again. So mainly reaction will be of Br minus and Ba plus 2. The observable changes with H2SO4 will be BaSO4. Okay. लिखने की जरूरत है या फिर इस तरह से हो जाएगा? If you want, you can write all the cases. What will be the formation of the products? Okay, so in case of BaBr2, here BaSO4 will be formed as white precipitate, AgBr, yellow precipitate. In case of O3, it will convert into Br2, barium sulfate again, and in this situation also Br2. So all answers will be there in this case, PQRST. Third option is NaNO2. What are the observable changes? It will form HNO2. HNO2 will give us NO2 plus NO. Case of AgNO3, it will give AgNO2. This will be precipitate. In case of O3, it will get oxidized into NaNO3. Yes, NaNO2 in presence of acidified FeSO4, it will give Fe2SO4 whole thrice plus NO. And again, in this situation, it will convert into NO3 minus because H2O2H plus is stronger oxidizing agent than HNO2. So again, all answers will be there. Last is Na2S. In this situation, it will give fumes of H2SO4, suffocating rotten egg-like smell. It will form Ag2S, black precipitate. It will oxidize into sulfur or sulfate. In case of FeSO4 and slight acidic medium, it will be giving H2S gas only. And in oxidizing agent, it can form sulfate again or H2SO4. Okay. So all answers are PQRST except A, which is PQST. Okay.
Yes, sir.
Fine. Any doubt in this question? In any part?
Sir, in case of H2O2H plus, Na2S oxidizes to Na2SO4 or sulfur?
Mainly in the acidic medium, it can go up to highest state. In O3 medium also, in case of ozone also, we can write that as a sulfate. Finally, it will be sulfate. Okay, here also it is sulfate, and here also it will be finally sulfate because these are strong oxidizing agents. Na2S. S2 minus will convert into sulfur, then to H2SO4 till H2SO4 can go. Okay.
Yes.
Any other doubt? Okay. Try solving these questions. These are some end questions, objective, integer level.
3, sir.
Yes, very simple question. Any other guesses? Any other answers? Okay. So answer is dilute HNO3. Dilute HNO3. Concentrated HNO3 and concentrated H2SO4. The answer is 3. Okay. What is the logic? That these 3 are oxidizing as agents also, oxidizing acids. So copper is also less reactive than hydrogen. So normal H plus giving will not react. Non-oxidizing acids will not react. So dilute HCl, concentrated HCl, HCpO4, H2CO3, they are non-oxidizing acids. And H plus is also can't be reduced by copper. Therefore, the answer is 3. Okay. Try attempt next question.
8, sir.
Yes, very good. Other students also try. Okay, so in this question, BaSO4 with coke will give us sulfide. On reduction, it will form BaS, S2 minus, basically, sulfide. And the next reaction is sodium nitroxide test compound finally forms Na4 FeCN5NOS. Okay, this will be Y. यहाँ तक idea लग गया होगा. Now you have to find the total number of electron present in T2G orbital of Y. Okay. So answer of A will be, in this situation, it will be 4 minus, this will be -1 multiplied by 5, overall -6 inside, outside -4, that means it is Fe plus 2. And in this case of Fe plus 2, there will be 6 electrons in the T2G orbital. And inner orbital complex D2sp3 will be formed. Okay, in case of D2sp3, the d orbitals will be dx square minus y square and dz square. Okay. So number of axial d orbital participate in habitation is 2. Answer is 8.
Sir, in this question, are we considering non-decomposition of exuvate?
No, we are considering its decomposition. We have to first do the hydrolysis of XgF4. If nothing is mentioned, we are considering it at room temperature, right? So the final answers will be the on the complete hydrolysis of xenon F4.
Is it 3?
What are the values of X and Y?
X is 0, Y 3.
X0. Okay. So you will be getting the product as xenon and xenon O3.
Yes, sir.
Xenon O3 is explosive or not? It is a
Isn't
explosive substance.
isn't xenon O4 explosive?
Xenon O3 is also explosive.
Okay.
Xenon O4 actually do not exist. It converts into other compounds, but xenon O3 is also considered as explosive, but it can form in the reaction. It will not further convert into anything. Okay. The
Yes,
nature
sir.
of xenon O3 also explosive. Okay. The hydrolysis of xenon F4, complete hydrolysis will be like xenon F4 in 12H2. It will give us 4 xenon, 2 xenon O3, 3 O2, and 24 HF. So in this situation, the balancing is important. I'm writing the complete balance equation. So in this situation, how many explosive substances are formed? X equals to 2. Xenon O3 is also explosive. And total number of moles of paramagnetic substances formed. Okay. So paramagnetic substances O2, that means 3. Okay. So answer will be 5. Okay. So this is important hydrolysis reaction. Fine. Any other doubt in this case?
Clear, sir.
Attempt next question. This is last question for today's session. Okay, so basically the question is I minus in presence of P, it gives a blue color. So that will be starch iodine blue complex, right? So I minus will be converting into I2. So you have to just find the oxidizing agents which can convert I minus into I2. So they will be like IO3 minus, Cl2, H2O2, FeCl3. No, I don't think FeCl3 will work it in this manner, like oxidizing behavior or not. H2S will not work. NO2 minus can work because it is oxidizing agent. Okay. But in case of FeCl3, it will form FeI3, which we already discussed that it is unstable. It will convert into FeI2 plus half I2. And again, in case of CuSO4, it will convert into CuI2, that is again unstable, Cu2I2 and half I2. Okay. So these 6 will be the answers. Okay. Clear? Because internally Fe plus 3 will act as an oxidizing agent. I minus will be acting as reducing agent. Again, copper plus 2 and I minus. Oxidizing agent, internal, intramolecular redox will take place in these situations. Fine. Any doubt? Answer will be 6. Any doubt in this case? Getting the idea?
Yes, sir.
You have to first find the type of oxidizing agents, but in case of FeCl3 and CuSO4, you have to find these reactions. Okay. So we have ended this quiz again. This is our second quiz. Okay, hoping you are liking the questions.
Yes.
the way they are framed. They are easy also, and they are up to ITA advanced level also. Okay. Okay, fine. Any other doubt, or we just end up the class?